Hi guys, I'm Mrs. Roberts and this is Math Made Easy by Mrs. Roberts. In this video series, we are going to learn about rectangular versus polar coordinates. Specifically, we are going to define polar coordinates and then we're going to learn how polar coordinates are related to rectangular coordinates. So, what is a rectangular coordinate? Well, a rectangular coordinate is what we've been working with since the fourth grade. It is an ordered pair in the terms of x and y, and you graph it on your normal Cartesian coordinate system. And what's a polar coordinate? Well, a polar coordinate is another way to look at graphing something. And instead of looking at x and y, the vertical and the horizontal distance, we are going to look at the distance away from our polar axis, or the radius, and we are going to look at the angle. So let's go ahead and talk about that a little bit now. So what you see on the screen right now is our normal Cartesian coordinate system. X and Y, good old trusty X and Y. And what we're going to do is we are going to graph an ordered pair. Let's graph the ordered pair 3, 4. Now, you've been doing this since the fourth grade. We are going to count over 3, 1, 2, 3. And our horizontal component is 3. We went in the horizontal direction 3. We're going to count up 4. 1, 2, 3, 4. Our vertical component is 4. And there's our ordered pair 3, 4. So 3, 4 tells us our location by telling us how far to move horizontally and how far to move vertically. Now, what if I wanted to make this into a right triangle so that I could figure out the angle in which this ray has come out of the origin? So this ray is coming out of the origin, and the distance this ray is, we call r. The distance of that ray we call r, and we could graph this if we knew what r was and if we knew what the angle theta was. Lucky for us, we can solve for both of those because right here with 3 and 4, we can make a right triangle. Our horizontal component is 3. Our vertical component is 4. That's a right triangle. And so that means we can use Pythagorean theorem to solve this. 4 squared plus 3 squared equals r squared. 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, and r is 5. Now, how do you know r is 5 and not negative 5? That's a good question. For now, let's assume that it's the positive 5. There is such thing as a negative 5. And what that would tell you is what direction you are coming out of the origin. So we figured out our ray. Is there a way to figure out the angle? Is there a way to figure out theta? Well, this is a right triangle. This is a right triangle. And we know 4 and 3. And 4 and 3 could be related to that angle using tangent. Yeah, tangent of theta. Oops, I clicked a button. Tangent of theta is 4 over 3. It is opposite over adjacent, which means that we could find theta by taking the inverse tangent of 4 over 3. Of course, I don't know that off the top of my head, so I would need to go to a graphing calculator. And my favorite one to use is Desmos. So let's go ahead and pull Desmos over here. And let's use the calculator. So in functions, we can find the inverse tangent, and we want to do 4 over 3. The calculator is going to give this to us in terms of radians. This is going to give it to us in terms of radians. If you click this wrench, you can change it to degrees. Sometimes degrees is a little bit more intuitive. I know where 53 degrees is better than I know where 0.92 radians is. But those are equivalent, just different forms of measurement. So 53 degrees is what this theta is. So that means that if I wanted to graph this, I could draw an initial ray there. I could go 53 degrees. So I want to go 53 degrees, and I would just want to make sure that I make my ray 5. That's probably not 53 degrees. 53 degrees has to be a little bit more than 45, and we would just need to make sure that that ray is 5. Okay, so we know what a rectangular coordinate is, and we actually know how to find some cool information, the distance from the origin and the angle in which you're turning things, using the rectangular coordinate system. But what is the polar coordinate system? Well, as we kind of just talked about right here, the polar coordinate system uses distances and directions to specify the location of a point in the plane. Okay, so to set up the system, we are going to choose a fixed point, O, and we call that the origin or the pole. So right here, this is the origin, or sometimes you'll hear it referred to as the pole. That is the middle. And we are going to draw a ray coming out of O. This line here is what we call the polar axis. This is what we call the polar axis. Okay, maybe I should write that over here. So this is the polar axis. So r is the distance from the origin to the point, and theta is the angle between the polar axis and the segment OP. So let me type that out because I'm not so great at writing with the pen. So r is the distance from the origin to our point, and theta is the angle between the polar axis and the segment. And that segment is OP. So there's some vocabulary for us. Let me put a little line above this because that is a line segment. And the two big things here are r and theta. And when we are writing our ordered pairs, when we're writing our ordered pairs for the polar coordinate system, we write them in the term the point is r theta. That's not so bad. So this is what we've learned. We know a lot about the rectangular coordinate system. The polar system has kind of a funky little graph. R is the distance from O to the point, and theta is the angle from the polar axis to the segment. Now let's look a little bit closer at this graph before we start working through some examples. So looking at this graph here, what you will see are little circles, and each of those circles is a radius. It is a distance from the origin. So anywhere along this circle, I am 1 unit away from the origin. Anywhere along this circle, I am 2 units away from the origin. Anywhere along this circle, I am 3 units away from the origin. Anywhere on this circle, I'm 4 units away from the origin, and so forth. Each of these lines represents a certain degree. This is pi over 6, and if you remember, pi over 6 is 30 degrees. This is pi over 4, and if you remember, pi over 4 is 45 degrees. Pi over 3. And so where these points meet, where these two lines intersect, are certain points. So this point right here in the polar coordinate system, I could write as 4, comma, pi over 3, because I have my r and then my theta. This point here That point there I could write as 3, comma, 5 pi over 6, because I have my r and then I have my theta. So I hope that gave you a little bit of background on polar versus rectangular coordinates and how they are related. In the next video, we're going to do some practice graphing polar coordinates.